Hey there, this is Seth Schaefer from Team Just Cause Robotics. Today we finally return to my mostly 3D printed 1-pound Antweight bot mini Mulcher. In today's video, I'll be showing some weapon tests, talking about what changes I've made to the design and electronics since last time, and discussing what else I might need to change moving forward. While you check out the weapon test, I'd like to say a big thank you to all of my viewers. I've been making and posting videos on this channel for about 8 months now, and at time of filming I've just hit 305 subscribers. For such a niche topic as combat robotics, I'd consider that to be a success. And the more people I have watching these videos, the more motivation I get to create more of them. It really helps out with the YouTube algorithm when you like and comment on these videos, so if you think this channel deserves a wider reach, I'd appreciate you doing so. My goal with this channel isn't to make money. I can't even run ads until I get 1,000+ subscribers. It's to spread my love for the world of combat robotics and help others get involved. Getting my videos recommended to more people, especially those who might not search them out, is how I'm hoping to accomplish that goal. So if you love combat robotics, be sure to like and engage with all combat robotics videos you watch on YouTube, not just my own. Before we talk about that test, let me briefly touch on what's changed from last time. The reason this video is being made today after I started this project months ago is that the super small receivers that I ordered took 55 days to arrive for some reason. Supposedly they were through US Customs in late March, but then got stuck in a sorting facility or something until I finally got them on Friday. So Friday I soldered one together, quickly realized I had a few issues actually fitting it inside the robot, and then went back into CAD, splitting off version 0.6 into a version 0.8, added extra room at the front as well as behind, cutting out some material that was in the way of the wires, and I added little protrusions behind the wheels to prevent wires from getting caught in them. I remodeled the receiver to make sure it would fit this time as well. All of this was Friday night, and after 7 print hours, I had a brand new PLA chassis and lid on Saturday morning. On Saturday, I began my day trying to fit the electronics in the new chassis, only to find that the wires were all in the way. I cut and resoldered a bunch of wires to shorten the runs and allow them to flex where needed. As you can see, the ESC now has less than an inch of wire before the XT30, and I had to redo the link wiring as well. After finishing all of this, I plugged in the battery, popped in the link, and smoke poured out of all of my wiring. I had soldered the ESC's XT30 on backwards. What a facepalm moment. After that, the LiPo was reading as under 2 volts, so it's definitely toast, and the ESC was dead too. I had to solder a new ESC to the motor in XT30 correctly this time, after which everything worked as expected, and I got the robot into the test box. The spare battery I grabbed was only at 60% storage charge. Okay, so let's talk about what you just saw. Firstly, on Saturday I had the hastily swapped ESC, which was previously programmed as a spare for Drakenid's drivetrain, so it had been set up for reversing, which isn't needed for a spinner weapon, and also made it really annoying to control. I forgot at first that the weapon still wasn't vertically constrained, so it popped up again, and this time when I tried to slow it down, the motor spun backwards, which destroyed about 1/3 on the top of the teeth of the motor gear. For my second test, I used electrical tape to constrain it, which worked way better, but it was still very unstable as you can see. I developed a headache after this, so I didn't test anymore on Saturday, until this morning on Sunday when I decided to experiment quite a bit more with how the weapon system could handle these stresses despite being unstable. With a new pair of gears, properly constrained weapon, and a fully charged battery, things went a little differently. I decided to try driving around a lot more with the weapon at various speeds. Until it hit something, if I ramped up the speed slowly enough, the robot remains stable until maybe 80 to 90% throttle. But if I punch the throttle, or it jerks a bit the wrong way, it instantly starts coining around with weird gyroscopic effects. One time it even flipped upside down. I tried running the weapon upside down to see if it could self-right, but with nothing stuck onto the shoulder bolt to give it any leverage, just bounced around chaotically, until eventually the chassis spun so fast the link was pulled out from centripetal forces, even when I taped it to the side. Amazingly, despite all of these impacts and abuse, the chassis was basically fine. It has one nick on it that it got from hitting the aluminum L bracket I had bolted to the floor of the test box during my first test, but absolutely no damage from anything after that point. None of the electronics seemed to mind the extreme G-forces either, which is awesome to see. The printed weapon did crack from the hard hits it was delivering, despite having almost no tooth to speak of. I think when I do get a metal weapon on here, I might use a 3D printed stabilizer of some sort to try and lessen these effects. But first, I need to see how it does with a bar-like weapon versus the more disc-like weapon I'm testing with. I'd like to go a bit more in depth about the electronics for Mini Mulcher and how it's wired. So you can see all the electronics in here. So we've got the motor. We've got this weapon motor here, which is a special Cobra motor that I have linked previously, and I can link it again. Then we have 2 servos that I've converted for continuous, and there's a video where I did that, and you can see a card that I will probably link above. We've got my removable link, which is just an XT30 connector, which takes power from the battery line and disconnects it when you pull it out. Otherwise, it wires the power through to everything else. My wiring harness here splits out the voltage from the battery to the input of the BEC here, and then also to the input of the ESC on this side, which is just a BLHeli 35 amp I've pointed out before. We also have the output of the BEC wired to this red plug here, which then feeds power to the receiver at 7.4 volts. And I just wired that to channel 4 because I'm not using that. You can see channel 3 is wired just to the signal wires for the ESC, and then channels 1 and 2 are the signals for the 2 servos. Those servos are just configured for drive, so I can swap those 2 channels if I need to make it steer properly. And then I have the battery plugging into this XT30 here. If I ever were to enter this bot in an Antweight fight, I would need to survive getting hit by the opponent and be able to demonstrate controlled movement every 8 to 10 seconds. Despite the extreme lack of control the bot can develop after an impact, I'm pretty sure that would happen regardless of how stable it is when sitting still. So I'm not that concerned about it, because I can always just turn off the weapon and show that it will stabilize and drive controllably again. My main concern is that the weapon can't spin up quickly without it totally losing control, even when it's sitting still. And I'm not sure yet how the chassis or the gears will handle the impacts from a metal weapon against the arena walls. The loss of stability when it hits things is somewhat concerning, but also super predictable for pretty much any large horizontal spinner. I'm only really worried about the bot getting flipped over and being unable to self-right, because as scary as it looks, the air hockey death tornado mode will still damage my opponent, and if my bot keeps working, that's what really matters. Thanks for watching. Feel free to subscribe for more, and if you really love what I'm doing, you can always purchase CAD models from my web store to support me, linked down below. Check out my Instagram if you'd like to get some sneak peeks of what I'm working on throughout the week.